Hello students, let us continue the revision in the chapter Geometry. In the previous session we have solved till question number 58. We shall continue from question number 59 onwards. Here the question is in the figure 2.37. Name any four angles that appear to be acute angles. And there is a second sub question, name any two angles that appear to be obtuse angles. Let us do one by one. In the first, we will mention all the acute angles which are present in the figure are angle AED, ADB, angle ABE, and angle ECD. Second, the obtuse angles which are present in the figure are angle BCD and angle PAD. Let's do the next question. Question number 60. In the figure 2.38, we need to check these three options. The first one is AC plus CB equal to AB. Second is AB plus AC equal to CB. And the third is AB equal to BC, which is equal to CA. Look at AC, it is the line segment AC plus the line segment CB will be equal to AB. It is true. Whereas in the second, AB plus BC equal to CA is not possible. AB plus AC equal to BC is also not possible. The reason is AB minus AC will be equal to CB. Instead of plus sign there, it has to be minus. Same way, the third one is not possible. So no, the reason is AB minus BC will be equal to CA. Let's do the next question. Question 61. In the figure 2.39, we need to check whether what is the value of AC minus AC, AE plus EC, AC minus EC, BD minus PE, and PD minus DE. The sum of AE added to EC will be equal to the line segment EC. AC minus EC will be equal to AE. BD minus BE will be equal to the length DE. BD minus DE will be equal to the length PE. Let's take up the next question. Using the information given, name the right angles in each part of the figure 2.40. In total, there are the figures named as A to H. We have to look into each figure and write and mention the right angles. Let's do one by one. In the first, we have BA perpendicular to BD. So there is a right angle which is angle ABD. The right angle is angle ABD. Same way we will do for all the right angles. Let's solve the next question. In the next question, question number 63, what conclusion you can draw from the figure? Here they have given BD is a bisector of angle ADC, which means BD will divide the angle ADC into two equal parts. We need to mention the equal parts. So GB is the bisector of angle ADC. This implies that angle ADB will be equal to angle CDB. Next is BD bisects angle ABC. Therefore, this implies that angle ABD will be equal to angle CBD. Next we have DC, the bisector of angle ADB, and also CA perpendicular to DA, and CB is perpendicular to DB. So there are two parts which are to be written here. They are angle ADB is getting bisected by DC, which means angle ADC will be equal to angle BDC. This is the one of the part. One more part is, since there are perpendiculars, CAD angle will be equal to angle CBD and both measure 90 degree. Question 64. An angle is said to be trisected if it is divided into three equal parts. In the figure 2.42, angle BAC equal to angle CAD, which is equal to angle DAE. How many trisectors are there for angle BAE? Since it is given that angle BAC equal to angle CAD equal to angle DAE, it's been done with two of the line segments AC and BD. So there are two bisectors for these three angles. They are AC and AD. Therefore, the two trisectors are AC and AD. Let's look at the next question. Question number 65. Question 65 is, how many points are marked in the figure 2.43? There are only 2 points which are marked here. They are point A and point B. Question 66. How many line segments are there in the figure 2.43? If you observe, there is only one line segment. The line segment is the line segment AB. Question 67 and 68 together I have taken as both the questions. There's a common figure 2.44. How many points are marked? There are 3 points marked, namely A, B, and C. How many line segments are there? That we have to write them separately: A, B, B, C, and A, C. So there are three line segments and 3 points. Now we have question number 69 and 70 taken together since they have the same figure. How many points are marked and how many line segments are there? If you observe, there are 4 points and there will be 8 line segments. The 8 line segments are AB, AC, AD, BC, BD, and CD. In easier way, there are 5 line segments and sorry, 10 line segments and 5 points. Next, we have question 73. There's circle with the center boom mentioned. We need to name all the cards of the circle. Here, there will be 2 cards, PC and AB, RBA. Name all the radii of the circle. Here, the radius is the distance between the center and a point on the circle. So, BO, OP, OC, OA, they are the radii. Next we have name a card which is not the diameter. There is only one card which is not the diameter, that is PC. In the question 5 and question 6, we have to shade the portion. I have I'll shade the portion of uh, part D using a black color and part E using a red color. So black shaded portions, they are the sectors, and the red portion will be the segment, which is a smaller segment. Question number 74 is we need to identify two acute angles whose sum is an acute angle. Why or why not? First one is the sum of two acute angle will be always acute angle. The sum of two acute angles can be a right angle. Sum of two acute angles can be obtuse angle also. but it is not possible to have a straight angle and the reflex angle. The reason is being mentioned with one of the example. Question number 75 is similar to the previous question. We need to identify two obtuse angles whose sum is a reflex angle. Here we may consider 135 added to 100 degree. Both obtuse angles, their sum is reflex angle. Means the sum should be less than a complete angle. For the second, it is not possible to have because the angle should range from 180 till 360. In the next one, we have to identify the prism's vertices, prism's edges, and also the faces. Here we have to count all the vertices. There will be 6 vertices. They are the vertex A, vertex B, vertex C, vertex D, vertex E, and vertex F. There are totally 6 vertices. If you count the line segments, they are the edges. There will be line segment AB, line segment BC, line segment AC, the line segment DE, EF, DF, and also PD and AE and CF. Totally, there are 9 edges. You count the number of faces, there will be 3 rectangular faces and 2 triangular faces. In total, there are 5 faces, namely the face which is rectangular is ESCF, EDBA, the triangle ABC, the triangle DEF, and one more rectangular portion of the face is DBCF. Here I would like to bring it to your notice that there is a beautiful formula for this relation. F plus V will be equal to E plus 2. The number of faces plus the vertices will be equal to the number of edges plus 2. This is a famous result. This result is given by a mathematician named Euler. 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 Euler's formula. Here we have 9 plus 5 plus 6 will be equal to 9 plus 2. This formula is called as Euler formula.